Okay, this video is going to look at finding a polynomial function given its zeros. So in a sense, we're going to work backwards. So before we were given the polynomial function, we wanted to find the zeros. Now we have the given zeros and we want to come up with the polynomial function. So we have 2 and 5i. And now keep in mind, we have 5i is a given zero. And remember, our complex zeros occur in these complex conjugate pairs. So if 5i is a zero, then that also means that a negative 5i must also be a zero. So here, that tells us that our polynomial has 2 5i and a negative 5i as its three zeros. So simply, if 2 is a zero, then that means that x minus 2 is a factor. And if 5i is a zero, that means x minus 5i is a factor. And if negative 5i is a zero, that means x plus 5i is also a factor. So now, basically, here is our polynomial. All we have to do now is multiply out the factors, and we want to multiply your complex factors first, because when you multiply the complex factors, you're going to easily eliminate the imaginary part. So here we're going to get x times x is x squared, and when you multiply the x and the 5i, we get a positive 5xi, and here we get a negative 5xi. So that middle term is going to cancel out. So then you have a negative 5i, a positive 5i, so that's going to be a negative 25i squared. So then if we continue to simplify that before we multiply, you would have x squared. And remember, you have a negative 25, and remember the I squared here is really equal to a negative 1. So negative 1 and negative 25 is a positive 25. And I want to point this out. Notice we have x squared plus 25. Well, if you were to take this x squared plus 25, if you think about setting this equal to 0 and trying to solve for x, you could have x squared equals a negative 25. And at this point, we used to always say, well, there's no real solution, because if we try to take the square root of both sides, we would say we can't take the square root of a negative number. But if we're looking at our complex numbers, we know that would be a plus or minus 5, and then the negative makes it plus or minus 5i. So anytime you see an x squared plus a number like this, that's where you're going to get your complex zero, or in other words, this case, when you multiply this out. All right, so now all we have left to do is to multiply. So we're going to distribute the x. X times x squared is x cubed. X times 25 is 25x. And now distribute the negative 2. Negative 2 gives us a negative 2x squared. And then negative 2 and 25 is a negative 50. And if we arrange this in descending order, we would first have x cubed minus 2x squared plus the 25x minus 50, and this would be our polynomial function that has the zeros 2, 5i, and negative 5i. And once again, we had three zeros, and that means that here we have our largest exponent is also a 3, because we had 1, 2, 3 zeros. All right, the next example. We have 6 and 3 plus I are the two given zeros. And hopefully now, once again, we know if 3 plus I is a 0, that means that 3 minus I is also going to be a 0. So that means that if 6 is a 0, that means that x minus 6 is a factor. And that means that 3 plus I is a 0, so that means x minus 3 minus I is a 0. I'm sorry, a factor. And if 3 minus I is a 0, that means that x minus 3 plus I is a factor. And if you don't see where this is coming from, if we think about taking this as if x equals 6 and if x equals 3 plus I and x equals 3 minus I, if you were to set each one of these equal to 0, you would have to, in this case, subtract the 6, and here we would have to subtract the 3 and the I, and here you subtract again the 3 and you would add I. So that's where we're getting these factors from. Now, there's a couple ways we can do this. Again, you first want to multiply your complex factors here together first, because that's going to eliminate the imaginary number a lot easier than if you were to multiply these two factors together. Now, there's two ways you can multiply this. One way is you can take and distribute the x to everything here, okay? Then, because this is a trinomial, you'd multiply the -3 by each piece. And then you could distribute the -I to each piece. And then you can combine all of your like terms. Okay, so that's one technique. The other technique is what I'm going to use. And if you look at this, we have x, and then I'm going to write this as x minus 3 minus I. And then here we have also an x minus 3 plus I. So if you look here, I'm grouping the x minus 3 together. So here we have your x minus 3 and x minus 3. Now think of that as one term. For an example, if we had a minus b times a plus b, if you were to multiply this out, a times a becomes a squared. And again, what happens here to this middle term? We have a positive AB, a negative AB, so that's going to cancel out. So then b times b is a negative b squared. Okay? If you look over here, we have the same thing. We have our a times a would be the x minus 3, and the b is the I. So it's minus b plus b. So in other words, here it's minus I and plus I. So to make this a little bit easier to multiply, by the rule over here, we're saying that we're going to take a squared. Well, our a is the x minus 3. So that means this would be x minus 3 squared. And then it's minus b squared. So that's minus the I times I, which is I squared. All right, so now all we have to do is simplify this expression. And if we have x minus 3 squared, now remember, how do we factor something like a minus b squared? Well, the shortcut is you square the first term, you multiply the two terms together, so that would be minus ab, but then we have to double that, so it's a negative 2ab plus b squared. So we want to do the same thing here. So we're going to end up with, now again, if you don't like to use the shortcut here, x minus 3 squared, you can think of this as x minus 3 times x minus 3, where you're going to FOIL this out. So we're going to end up with x squared minus 6x plus 9 minus I squared. Now remember, I squared is really what? I squared is a negative 1, so that would be plus 1. So that means we end up with x minus 6 times x squared minus 6x plus 10. All right, now at this point, I know this is a lengthy problem. All we have to do now is distribute the x. So we're going to distribute the x to each piece. So we would have x cubed minus 6x squared plus 10x. And then we'd come back and distribute the negative 6. And we have a negative 6x squared, a positive 36x, and a negative 60. And if we combine our like terms, we only have one x cubed. We have a negative 6x squared, a negative 6x squared, so that's a negative 12x squared. And we have the one, let's see, 36x, and let's see, wait a second, I made a mistake here. When I distribute the x, we should have had x cubed, 6x squared, and this should have been a 10x. Sorry about that. So now we would have 10x and 36x, which would be a positive 46x, and then we have the negative 60. So this here is your polynomial function given these two zeros. And again, we're given only two zeros, but we know that 3 minus I is a complex zero that occurs with a conjugate pair. So once again, we had three zeros. So notice our exponent here is 3. All right, so here you have two examples. If you're given the zeros of a polynomial, how you can easily find the polynomial function.